What if I told you that playing around with drones and social media handles could assist in disaster management and do something great for mankind? My name is More Blessings Shoko, a geomatics academic from the Faculty of Engineering and the Built Environment at UCT. Today, I will share with you some insights on how built environment professionals like myself and others can play all day and sometimes all night and still call it work because we still deliver on contributing towards the 2030 Agenda for Sustainable Development. To begin with, it is important to appreciate that geomatics is the art, science, and technology of making measurements about the Earth and its surroundings, often done in order to create maps that support key decisions. Traditionally, the instruments used to achieve the high levels of accuracy required in this profession are distinct and commonly seen in construction and built environments where data collection can be in progress. My talk today hinges on the roles of some of the disruptions as instrumental research tools for modern mapping. Specific to mention is the role of drones or unmanned aerial vehicles, and also the role of humanity as sensors broadcasting location data through social media spaces like Twitter. I will outline how all these relaxed and play-like environments are proving very instrumental in our project mapping approaches. In much of the global academic and media discourse, wildfires are characterized as an increasing threat to socio-ecological safety. My interest in disruptive technology for spatial data collection has spanned over a decade, but more specifically, the interest in drone technology for mapping culminated in 2017 when I won an international award for pitching a drone for sanitary pad innovation. Fast forward from that moment, I was able to train and sign out as a registered remote pilot license holder, and that accelerated my research around the subject of drone tech. I also have taken interest in social platforms, running a career campaign on TikTok, Facebook, Twitter, YouTube, and Instagram. So the reality to show the strength of some of the data from these spaces, especially data with the location tag, has gradually grown on me and found its way into my research path as well. The work I describe today has also been contributed to by a team of energetic postgraduate students in the form of Daniel O'Sullivan Hewlett and Diana Abejo-Rose. The main project I will share on speaks to the use of structured and unstructured data in post-fire management. The aim of the study is to map, model, and quantify the effects of the wildfire using a novel approach that blends multiple datasets, with the case of the April 2021 Table Mountain Fire as a study site. In order to meet its aims, the study employs remotely sensed and unmanned aerial vehicle data in order to create a holistic report on the event. The study establishes long and short-term pre-fire conditions by statistically analyzing imagery and auxiliary data. It also creates a visual timeline of the fire event itself using unstructured social media data and detects spatial extent of the fire through supervised classification and burn indices. Moreover, there is the collection and using of UAV data for modeling of damaged infrastructure in order to quantify the extent of the fire and impact on infrastructure. I will also throw in highlights of a project on the use of UAVs in land administration that is ongoing. Both projects speak to the 2030 Agenda for Sustainable Development, which reaffirms the urgent need to plan around disaster mitigation in society, where location or spatial data plays a key role in the logistics around this agenda. Some of us may recall that in 2021, there was a fierce Table Mountain fire that occurred in the southern suburbs of Cape Town in South Africa. It engulfed a number of historical, material, and infrastructure, including part of the UCT campus. It is important to note that fires are common in Cape Town in both formal and informal areas of habitation, and our many projects over time have looked at both areas in terms of mapping. The Table Mountain fire selected for this talk makes an interesting use case because there was high publicity around it and a supportingly large volume of tweets as the fire progressed, which is helpful to our unstructured data collection. After or during the occurrence of the devastating events such as fire, the primary focus is on the search and rescue. Although search and rescue also rely on maps, our focus was on post-fire damage quantification and the use of Twitter as a window to look back in time as we review the damage to both natural and built environments. For most wildfires in South Africa, there currently remains little or no scientific or detailed public report on the fire and the associated damage. Much of the available information relating to the fire comes from unconsolidated news articles, which are often quickly outdated, prone to error, and are often not rigorous, all of which make it difficult to create a comprehensive overview of the event. There is also little or no scientific or forensic outputs, such as the fire statistics on the affected area or burn maps existing either. Through documentation of wildfires, particularly in wildfire-prone regions, it is critical for long-term fire management. This is the motivation to investigate fire and create an integrated report for the purposes of public information, scientific analysis, future wildfire management, and historical archiving. We settled for a partly unstructured mapping approach that mined tweets that spoke to the progression of the fire as it happened, and we compared the Twitter-derived timeline to outputs from structured map outputs that verify the tweets. In our structured mapping approach, we decided that post-fire drone survey would be very helpful. Drone footage would allow us to quantify damage to buildings in the main and vegetation on parts of the sites. We also needed information on the extent of burn scars on the mountainside and opted for a cloud-based analysis that relies on multi-temporal datasets that allow us to walk back in time. This cloud computing space is Google Earth Engine, and it allows even non-expert users to develop simple rule sets to extract temporal data that they require that speaks to the problem statement. From the cloud data, we established the number and extent of burn scars, mainly on the vegetated sites, and we were able to verify some of the scars on the drone imagery as well. The drone footage itself gave us three-dimensional models of buildings affected by the fire, and the resolution can be so useful that one is able to detect damage at such a fine scale. The case of the 2021 Table Mountain fire was used as a case to curate, to create burn maps and three-dimensional models, which were then used to measure, to indicate damage-built areas and natural areas in selected space. So, to conclude this, a recap of the highlights. Our work summarizes the role of innovative methods of spatial data collection to curate post-fire environments using Cape Town as a case study environment. The main project looks at combining modern platforms such as UAVs, cloud-based computing repositories, the novel use of unstructured datasets from Twitter and others to provide up-to-date detail in disaster situations. Evidently, UAVs are revolutionizing mapping paradigms. In a similar project, we are looking at the role that drones can play in cadastral surveying, securing land rights and land tenure security, especially for vulnerable communities. Our work will focus on rural and communal areas where often boundaries remain undocumented due to exorbitant costs of geomatics practitioner services. We test the place of machine learning and related computer vision approaches in automating boundary detection for land tenure-related imagery. The use of disruptive technologies in mapping is rapidly gaining momentum and offers lower costs based on scale and application for decision-making around disaster management in both formal and informal areas. Thank you for listening to my presentation.